today's lecture, we will learn to draw the layout of a transmission gate. At first, open the terminal window by pressing Ctrl, Alt and T. Now this is the terminal window. Type magic -T SCMOS and the name of the layout. It's transmission gate 3. Then press enter and wait for the two windows to open. Now this is the layout window and this is the TKCon window. In the layout window, we cannot see any squares. So just type grid. If I want to clear all this, I can type clear and then type grid. So you can see this was my selected box, the selected square box. Now it has got to zoom, so press Shift Z to zoom out. Now we have to make the anvil first. So select the area, you need a bigger area, and then type paint anvil. Since I'm making the PMOS, I'll first paint with anvil and then with the P select. Type paint P select. Now press enter. So it should be P diffusion. Paint P diff. Since we do not have any term like P select, type P diffusion. After P diffusion, okay, we don't need this whole portion as the P diffusion. So let me undo it. I need to create two separate PMOS. So I'll select this portion first and then type paint pdiff and then select another portion and then type paint pdiff again. So these are my two PMOS. Now their corresponding NMOS. So I'll create a N diffusion layer, select the area, then type paint NDiff. So you can see this is my N diffusion layer. Then just below this I'll select paint NDiff. Okay, now we have to connect through the metal layer. So select the portion, directly I can select and I can type paint M1. So this is my V in, and next is my V out. Okay, I'll make it a bit longer, bit wider. So now this is my V out. So paint M1. So this is my V in, this is my V out. Now next I have to make the VDD. So type paint M1. So all we need metals for the connections. For any connection we need metal. Okay, and from here to here type paint M1. Okay, now my VDD is done. Now my ground, paint M1. Okay, my VDD and ground, they are done. At last I'll place all my contacts. So initially I'll finish this. After that I'll short this part. Paint M1. Okay, now have to extend. Okay, before going for the extension I need to place my poly. Let me keep it to 2 lambda, but I'm unable to. Yes, this is my 2 lambda. Now paint poly. Now from here select type paint poly. Now from okay, let me zoom out. Now need to zoom in. Okay, now paint poly. Okay, this is my extra part, so I'll select and press the middle key. Okay, now it will go through the two metals. Paint poly. Okay, now these are my gates, the connection between the gates, because we know that the poly contacts are used to connect the gates of the NMOS and PMOS. After this, we need a poly over here. Type paint poly, and there is a connection between this gate and this metal. So type paint M1. Now I have to connect this metal and this poly. So for connecting this metal and poly, let me place the contact over here. This is my poly contact, and then I'll select the area. Okay, let me zoom out. Okay, now I can place all my contacts. So placing my contact, the first one with the P diffusion contact. We'll start with the P diffusion contact. Select the area, type PDC, P diffusion contact. Paint PDC. So the two P diffusion contacts are placed. Here also P diffusion contact. Type PDC. Okay. Now over here, the N diffusion contact. Select the area and type NDC, N diffusion contact. Similarly over here also, paint NDC. Now if you want to save this layout at this level, then type save and TG3. So it has been saved now. After these contacts, we have ground and VCC. This is my VCC and this is my ground. So I need to place my NWC contacts. The N1 contact. It's a bit mandatory to place this contact. You shouldn't forget to place the NWC and the PWC contacts. NWC. So it should be PWC over here. Okay. After that, all the contacts are placed, and now the labeling. Let me clear the sticky icon window. Clear. So for the naming, let me select, this is my VN. So I'll select the area and right click on the left corner of this box. I'll type label VN, enter. You can zoom and you can see it. This is my VN. Label V out. After that, over here the VDD, and here to create a very small box and type label GND. So moving label GND from space to metal. Okay, now I want to save TG3, and next is to extract. It's extracting TG3 into tg3.ext. So my ext file has been created. Next is to convert this .txt file to .sim file. So extract to sim. Done. .sim file generated. If you want to see, you can go to the home folder and you can see my .mag is my magic file, the layout, .ext, .sim. Next, extract to the spice file. This is my spice file, and press exit. So this is back to my main window. So we have learned how to draw the layout by using the commands in the tick-icon window like paint, NDC, UP diffusion, and diffusion, etc. So now we'll learn how to draw the layout by using the toolbars present in the magic tool. So the same procedure, will open the terminal window by pressing Ctrl Alt and T. Then we will type magic -T, Essimos, Suppose I want to draw the layout of a transmission gate. Let me name it as transmission gate 4. Then press enter. Now this is my layout window. In the tick icon window, I'll type. Okay. Now I won't type anything on this tick icon window except the extract command and the save command, etc. Over here, I want to directly grid in. I will not type grid, but I want to grid in. Then I just press G in my keyboard. So when I press G on my keyboard, so I got this grid in. Same for the zoom out, Shift Z. Now, how will I do without using the paint commands? Go to options and there's a toolbar. Press the toolbar. So you can see all this N-well, P-well, this is the end diffusion, and this is the N-well, P-well, this is the N-well. Similarly, we have the end diffusion contact, etc. So now select the area, and then go for N-well. So select it. Press the middle key. Press the middle key of your cursor in order to select this N-well. Now take the portion. The area will be painted with a P diffusion, so have to search for P diffusion. This is my P diffusion. Press the middle key. Okay. I can undo. I have to select this portion and then the P diffusion. P diffusion. Now if I want to extend this, okay, now they're looking equal. Now here below this we have the end diffusion layer. So select the portion and then middle click on the end diffusion. Similarly over here, select the portion and end diffusion. Okay, so now we have to short these two. Okay, we need some more. Even I don't need to go here and press the middle button on my keyboard. I can directly press over here. If I press the middle key of the cursor over here also, I'll get it. So select the area and then metal. Here is the metal. Press the middle key of the cursor. So now this is my metal, this is my V in. Then again the similar we have to go to the V out. It's very difficult to select these areas. So now my metal, I need not go here. I can do directly from here. Okay. After this, the VDD and ground. Now this area my metal. This is my VDD. Okay, I want to extend one line more, so I'll select the area and press over here. Okay, now next we have to extend this line. Okay, now let me put the poly. So I'll select the area. So this is my polysilicon. Poly means polysilicon. Then okay, now the polysilicon will extend it like this. So even you don't want to go 100 times and come here and we'll select it. No, we can directly do it from here. So I don't want this portion. Select middle key. Okay. Now from here I'll take a polysilicon and from here the metal. Okay, from I need to place a polysilicon contact. So this is my poly contact. Press on the middle key. My metal. So this is the extra part, omit it. Okay, now let me zoom out. Okay. Now I'll place the other contacts. How will I do that? Select same procedure. Only thing we have to search the contact. So the contact over here is the P diffusion contact. This is the N substrate contact. This is the ND contact and this is the P diffusion contact. So here the P diffusion contact. Okay, so here similar way select and this is the PD contact. I want to extend it by a metal layer. I want to say uniformity in my layout. So that's the reason why I keep on extending. Now the PD contact. This is also my PD contact. So we had there PDC, here it is the PD contact, and here the NDC, N diffusion contact. Yes, we have, this is our VDD, so we have not taken the ground. Select the area and the metal one. Since this is the metal one, when we type in the command window, we type M1. Select the area and the contact. Okay. Now we have the N substrate and P substrate. So there we had NWC and PWC. So over here also we have to select the substrate contact. So there it will be N substrate contact here. This is the N substrate contact. So as much as substrate contacts you can place, it is better for the metal layer. And over here the P substrate contact. Okay. Okay. Now I'll save it, or we can directly, without using the commands, I can directly go to file and I can save the layout. Right. Okay. And next task is for labeling. So let me see my layout once again. So this is the layout of my transmission gate. Let me zoom in. Labeling is done in a similar way. Select the area and right click on the left corner. Type label. Then this is my VIN. Next. Label V out. Okay, my V in, V out. Next is my VDD. Label VDD. Next, this is my ground. Label G and D. Okay. We have one more label over here. It's my label E. Again I'll zoom out and then save. Now the same procedure, extract, so extract the sim, then ext2. The next file will be from extract. After the ext file, we'll extract it to the sim file, ext to sim, and then ext to spice. So we have tg4, sim, spice, magic file, and the ext file. Okay, now if we want to exit, now let's see the layout of a transmission gate that is drawn from the normal schematic. Open the terminal window, pressing Ctrl Alt T, then type magic, press enter. Now This is the layout window and this is the Tikecon window. First we have to type grid. Okay, now we'll draw the layout without using the toolbar. We will use only the commands. So first we have to draw the transmission gate. Transmission gate consists of one input, one output, and a select line and a select line bar. So first we have to draw a PMOS, then an NMOS. So paint anvil, erase. We don't need much of length. Now P diffusion, select the area, type paint pdiff. So now this is the PMOS and this is the NMOS. In order to draw the NMOS, type paint and diff. Now after drawing this PMOS and NMOS, we know the transmission gate, the drains of the two MOSes are shorted and the source of the two MOS are shorted. So before that, let's draw the poly layer just to show the gate terminal. We know here the gates are not shorted in the transmission gate. So type paint poly. Similarly over here, paint poly. Now remove this portion. Erase. Okay. Now let's say this is the source terminal and this is a drain terminal. Select the area and then type paint M1. So now the sources are shorted. This is the drain terminal since we'll obtain the output from here. So paint M1. Now we don't need this portion, so select, erase. Okay. Now since these two are shorted, we have to place the contacts. Select the area. This is the N diffusion layer. So paint N diffusion contact, paint NDC. Sorry, this is the P diffusion layer. So you have to place the P diffusion contact, undo, paint PDC. We know the color of this contact is bluish in color and the color of the N diffusion contact is green in color. paint PDC, P diffusion contact. So similarly, we need here the N diffusion contact, paint NDC. You can see it is greenish in color. It is so because the N diffusion layer is green in color. Now type paint NDC. Now this part of the transmission gate is done, the input and the output. If we want, then we can label this, select the area, and then right click on the left base. Then type label in, because this is the input terminal and this is the output terminal. So label it as out. This is in, this is out. Now this part is done. Now we have to design the select part, select line part. So we know the input to the gate is select, one gate is select and the other gate is select bar. So we need to design a inverter. Select the area, type paint anvil, then paint pdiff, zoom out, now paint paint and diff. Okay, now you have to place the poly layers, poly, so as to show the gate terminal. Paint poly, then paint poly, paint poly. So we can see the two gates of the inverter. This is PMOS, this is NMOS. Now let's design the inverter first. So this is connected, the source of the PMOS is connected to VDD. Paint M1, and this source of the NMOS is connected to ground. Now this is the VDD layer. Wait, M1. Paint M1. So this is the VDD and this is the ground. So let us name them simultaneously for our convenience. Label VDD, then label ground. Okay, now this is the select line. So the input is shorted. Paint poly, this is the select line. So let's name it as paint poly, label select, label SEL, because select is again a keyword. So this is select, and the obtained output, that is obtained from the common drain terminal of the PMOS and NMOS, will be the output. So select the area, okay, let's extend the paint and the paint M1. Now the two drain terminals are shorted. So let's place the contacts. Paint NDC, paint PDC. Similarly over here, paint PDC, paint NDC. Okay. Now the obtained output from the inverter is select bar. So let us label it as label SELB. So now this is the select bar, SCLV, and this is SCL. Now the select line, the select input is connected to the NMOS. So extend this, paint poly, paint poly. Now type paint poly. Basically we are trying to connect. Okay, so we didn't need so much extension. Erase. So this is connected to this. You select input. So directly from here, you can connect paint poly, paint poly. So now select is connected over here, and the select bar is connected to this gate. So extend the metal layer, paint M1, paint poly, paint poly. Paint M1. Now this region needs a contact, paint poly contact. So now the select bar is connected to this gate terminal. So we can see this is the twisted diagram, untwisted schematic converted to layout. Now save it. Save transmission gate 6. So let us find the DRC errors, if any. There are no errors. So now extract all, extract to spice, then exit. vi tg6 dot spice. So this is the width length 8363. Here the pivots are of equal length and there is the two end fits are of different width. You can see VDD select B. It's showing this is the gate, this is the source, and this is the drain terminal. Open it again. tg3.mag. Able to find it's tg6 actually. Magic tg6.mag. If I type tg3, then it created a new magic file. Okay, so this is the layout. We have given all the contacts for the N diffusion and P diffusion. So we have to place the contacts in the VDD and ground layer, the metal region. So select the area and type paint NWC. This is the N substrate contact. Similarly, type here paint NWC. Similarly, in the NMOS region, type paint PWC. This is the P substrate contact. Type PWC. Now save. Extract all. Then extract to spice. Then exit. vi tg6.spice. This is a spice file. Magic tg6.mag. So this is our layout. So this is the layout of a transmission gate.